Okay, we're back, part 2 of the power cycle. If you remember from part 1, what we were trying to do is to take an old discarded exercise bike and a discarded treadmill motor and put the two together to be able to generate power and charge a battery. One of the obstacles was to get the motor mounted to the frame, which we was able to do, as well as locate a drive belt, which we're also able to do. So we're doing good. On the motor, I was able to get a little piece welded on, which also allows me for a little bit of a pivot so that I can tighten up my belt for installation, as well as when it gets slack, I'll be able to tighten it up using that range right there. So far that's working out. That's working out real well. I've connected the motor to an old charge controller that we had. It's about 30 years old, and some of the electrolytic capacitors in it are starting to fail. So the load section of it, or the load control section of it, no longer works. But the charge portion is working good enough, at least for me to test a battery charge at this stage. I have connected a diode on the positive lead coming from the motor, and that's going to serve to allow energy or allow current to pass in one direction from the motor to the battery and not from the battery back to the motor, so that when I connect the motor or I connect the battery, the motor will not start to spin. It only pass current when the bicycle is being pedaled, motor is spinning, and then it'll pass current to the battery. I put a small 15 amp fuse, car fuse, in line to the battery just in case the controller shorts out on me during this test. The battery that we have is one that we had from the original solar system that we set up 5 years ago. And of course their life expectancy is only about 5 to 7 years, and its ability to hold a charge reduced down below what we needed it to do. So we upgraded our batteries, and this one's been out of commission now for about a year. We took it in to an auto shop and had it trickle charged to bring it back to as good as it can be. And I still think there's enough life in it to do some things. It may not run a refrigerator or a television, but I do think it will run 12 volt lights, and I think it'll run a 12 volt system to be able to charge a tablet or a cell phone. So the motor that we have, if you remember from part 1, is a 120 volt DC motor, and all I really need is about 12 to 15 volts of it. So I did some preliminary tests before I went any further on this project to see what I was going to be able to get out of it just by spinning the motor around by hand. And I calculated that for every pedal, every time the pedal went around, the motor's going to go around 22 times. So I kind of simulated that, or as best I could, by spinning it with my hand, and come up with some simple calculations to think that it's going to work. I think that a nominal pedal speed will give me somewhere between 10 and 30 volts. So we're going to put Maristella up here on the bike and see what we get out of it. Okay, found my power source. Alright, as you can see here, this is the state of the battery right now. It's at 12.7, which for this battery is probably full. Even though we call these things 12 volt batteries, the voltage at a full charge for a new battery is about 13.1. And when they get down around 12 volts, they're basically empty. And that may seem strange, but you don't want the battery to go completely empty. The range of use is really between about 50% of the total capacity to 100%, meaning that you don't want to take the battery below 50% at any point. So your operating range is between 50% of the battery's capacity, which in this case would only be about 12 volts, up to about 13.1 volts. This is an older battery, so full charge now is probably only 12.7. So I'm going to ask Maristella to start pedaling, and until she gets higher than 12.7 volts, there will be no current passing. And then you can see she's a little bit higher now, so at this point current is passing to the battery. Don't want it to get higher than 15. So somewhere around that, about what she's doing now is good. And this is what I hope. This is what the preliminary test I did. Figured I would be able to get this. Now she's not going to be able to pedal any faster than that, and of course any slower will be negligible. It won't be passing current. So that's as fast as she's going to be able to pedal without some type of voltage regulation, which is not bad. That seems to be a comfortable speed. Thank you. Appreciate it. So with our 14.4 volts, I've also taken some current measurements in here. So I'm getting about 4 amps at 14 volts, which is going to give me somewhere between 50 to 60 watts. And with 50 to 60 watts, that's per hour. In other words, it is generating 50 watts at any given time, but you give it 50 watts for an hour, you'll be able to receive, give or take, about 50 watts for an hour also. So, oh, my battery's going to die. I'm going to have to finish this segment in just a second. See, this would be a good application to charge the battery of my camera. But like we were talking about before, with the amperage that I measured and the voltage, it's giving me about 50 to 60 watts. 50 to 60 watts will power a couple light bulbs for a night, a couple of hours of television, hour and a half on a computer. So it's not an incredible amount of electricity, but being the light and charging the small devices would be huge. If I'd have been able to have a bicycle simply to charge a battery, or simply to ride for an hour and charge a battery to give me light for a night, that would have been a big deal when we first started this adventure. So anyway, hopefully it'll be useful, and hopefully I'll get to see a little bit more life out of this battery before she becomes recyclable. And thanks again for watching. And my next video on this bicycle will be when I actually connect it to my regular charge controller and operate it. And after I go through a couple of nights, I'll make another video of what we've been able to do with it. So stay tuned, like if you do, and subscribe if you want to get notifications or see more. Thanks again for watching.